Good afternoon all. So in the last class we have seen various activation functions and ANN architectures of the ANN building block. In today's session we will see ANN learning strategies. What are the different kinds of learning strategies? So we have covered that activation function, network architectures. Next we'll see the setting the weights. Setting the weights means it is training methods. So what are the various training methods or learning strategies for ANN? So before that, so as we were discussed in the ANN architectures, so different architectures have either single layer, multi-layer architectures based on its computed layers. So here any network to perform more computational tasks, it has input layer, hidden layer and output layer. So what is input layer means? Input layer, each input unit may be designated as an attribute and it is processed by that instance. Hidden layer, so it is not directly observable, but hidden layer provides the non-linearities for the network. So these hidden layers may be many or single hidden layer. So it depends on the applications. The computational depends on the computational task. So we have to decide that hidden layers number, and that depends on the architecture also. And output layer simply encodes the possible values from the hidden layer and gives as a output. So as the training requires weights adjustments, already we have seen that weights and bias updation means these weights are updated either with per sample manner or per iteration manner. You see that per sample updating means update the weights and biases after each sample. After each sample, the weights need to be adjusted. That is per sample updation. If it is per iteration updation, iteration or epoch updation means, so for few samples we'll make it as one iteration. So the weights and bias increments could be accumulated in variables till that iteration. Let us take for every 10 samples, if we are assuming that as one iteration, till the 10 samples of performance or process, the variables, what are the variables or weights will be updated in that variables, and after 10 samples or after one iteration as we were assumed, the weights will be adjusted. Till that point the weights will be as usual, like first sample, second sample and so on till the 10 samples. The weights will be, or the free parameters will be same. It will be adjusted after 10 samples as we were assumed 10 samples as one iteration. If it is 5 samples means after 5 samples of iteration the weights will be adjusted. So it will be like that. So that depends on the again conditions. For example, if you take the solar panel temperature will not vary that much instantly. For every seconds the temperature will not vary. So it has some time. For every 4 minutes or 3 minutes the temperature of the solar panel may vary. So we now need to change the weights or parameter for every second. So instead of that, till that point whatever the parameters are there, that can be same, but we are taking that every sample some till that 4 minutes or 3 minutes, we are assuming that that has a iteration. Till that iteration, all these samples will have the same weights. Then after 4 minutes, again whatever the free parameters are there, that will be updated for next 4 minutes. So that's what the per iteration training. So like we have seen this one also, all changes stopping condition means how these weights are used, are updated for the required operations in the training. That's what we are going through. So all the changes in weight in the previous iteration are below some threshold. So all these are as a part of the training process. So if you see that the del wij is less than threshold condition means we can set that stop condition, or the percentage of samples misclassified in the previous iteration is below some threshold. From earlier sample to present sample, if you find any difference, then that also can be treated as a stop condition. Or pre-specified number of iteration has expired. All these are based on the weights adjustments or updation only, which is part of the learning strategies. So a pre-specified number of iteration has expired. Let us assume particular applications required 10 iterations. After 10 iterations, we need to get that output means after 10 iterations that ANN has to stop its functions. Like that. So generally in practice, several hundreds of thousands of iterations may be required before the weights will converge, because before the weights will get the take this correct sample. So hundreds and thousands of iterations required to get the required performance from the ANN. So next one is, so based on these, the ANN learning methods are classified into 3 basic types. One is supervised learning, unsupervised learning, and third one is reinforced learning. We'll see one by one. This one is supervised learning. Here supervised learning, the name itself indicates that it needs some supervision. So with some supervision, it's going to learn something to get the required performance. For that, every input pattern that is used to train the network is associated with an output pattern, which is the target or desired pattern. So for every input pattern, there is a required or desired output pattern. We need to get the desired pattern by somehow. So next point, when a comparison is made between the network's computed output and the corrected expected output. Generally, any network or any controller will do that. It means what is the desired output, what is the computed output. So desired output is nothing but our desired output should match with that computed output, whatever the output we are getting it from the ANN. So when this comparison is made between that computed output and expected output, a teacher means who supervises that learning process. A teacher is assumed to be present during the learning process to determine that error. Simply, a teacher means some mechanism to supervise that learning process. So it requires a teacher to supervise that learning process to determine that error. When that error comes, by comparing that computed error and expected error, when you get that error, Now that error is used to change the network parameters to improve the performance. If error is more or error is less, by using that error we can change the network parameters to get the required performance or to improve the performance. That means if error is more, then what it indicates, the difference between the computed output and the corrected or expected output is more. So what we have to do, whether it is positive error or negative error, based on that either we can increase or we can adjust the weights of the ANN or free parameters we can adjust. So that's what the supervised learning. It's conventionally what we can see most of the times is supervised learning only. So weights need to be adjusted based on the error value. Second one is unsupervised learning. Here the target output is not presented to the network. In the unsupervised learning, we don't know the targeted output. Earlier in the supervised learning, for every input pattern there is an expected output pattern. But here in the unsupervised learning, we have input patterns, but the target output is not presented to the network. Hence, there is no teacher to present that desired patterns. Earlier in the supervised learning, a teacher is there to present that expected or corrected outputs. But here there is no teacher to present that desired patterns. Then what the system will do? The system learns by its own, by discovering or adapting to the structural features of that input patterns. Whatever the inputs we were provided, based on that it will learn by discovering or adapting to that structural features. There is nothing but inference capability here. It will take the inference from that input patterns and it will provide the output. It will think based on that input patterns, this may be the output, this may be the desired output. That's what it will provide in the unsupervised learning. So as there is no teacher, simply it will give the output based on the input values in the unsupervised learning. It means earlier in the unsupervised learning, what it will do is based on the input pattern, means like I have told you, if you are giving last 2 years data, based on that last 2 years data, what it will do is it will take some inference. The trends are like this. It may be increasing or decreasing, or it may increase decrease, or it may increase decrease again increase decrease. Some program it will do it based on the last or based on the provided input data. That means that is nothing but, if you are giving 5 years data, it will run that 5 years data, and that 5 years data, as per the structure of that 5 years data, it will project the next year data. The output patterns will be getting from that training. That means from that by discovering that input data, or by taking some inference from that input data. It is called unsupervised learning. Next one is reinforced learning. Here in the reinforced learning, the teacher is available. It means the teacher says something and he is available, but does not present that expected answer or expected pattern, output pattern. Here expected pattern will not be provided, but the teacher is presented. What is that mechanism. What is that role mean? What is his role means? Here only he indicates that the computed output is correct or incorrect. So here, whether the output what obtains from that ANN is correct or not, correct or incorrect, that can be decided or that can be provided by the teacher. Here the information is provided helps the network in its learning process. What are the information provided? That only helps the network in its learning process. That means it is like semi unsupervised learning. In supervised learning, complete teacher will be there. He can say that this is correct, or he can provide that error, and he can help in adjusting the weights. In unsupervised learning, there is no teacher. Simply based on that observation from the input patterns only, the ANN has to provide the output. In reinforced learning, teacher is available, but he will say either yes or no, correct or wrong. That information will be provided to that network. What it has to do ANN has to do, it has to learn from the information provided. It has to ANN needs to learn from the information provided. But the teacher, to improve that performance or to have that competitive learning, what teachers do is a reward is given for a correct answer. If ANN provides a correct answer, then a reward is given for every computed answer. A penalty is provided for every wrong answer in the competitions, so that ANN need to understand that it need to get more rewards. For that, whenever that penalty comes, it thinks that that is not the correct way of approaching to get the desired output. So it has to change in other directions towards that, to getting the more reward points. So that's what will be happen in reinforced learning. Next one is, it is not the popular forms of learning methods. So supervised and unsupervised learning methods are more popular than this reinforced learning. So the supervised and unsupervised learning methods are most popular forms of learning, and these have found expression through various rules. It has various rules to get the desired performance. Some of the widely used rules are mentioned below. One is Hebbian learning, gradient descent learning, competitive learning, and stochastic learning. What is Hebbian learning? We'll see one by one. What is Hebbian learning? So this rule is proposed by the Hebb in 1949. So this Hebb learning or Hebbian learning is nothing but it is based on the weights adjustment. Weights need to be adjusted to get the required performance. So this is the oldest learning mechanism inspired by the biology. So how do you need to adjust that weight? Means we need to get that weight matrix for every input output pattern pairs. Input output means xi, let us take it as input, and yi as output. For every input output patterns, there is an associated weights on the connection links. The weights matrix is assumed as W. Weight matrix, correlation matrix computed with the equation W, which is equal to summation I is equal to 1 xi into yi transpose. And these are vector matrices. So xi into yi transpose means in that xi is the input vector, yi is the output vector, yi transpose is the associated output vector of yi. So simply yi transpose is a transpose of yi vector. Y is output vector. So transpose of that associated output vector is nothing but yi t. That is nothing but transpose. So simply I think we have seen that yi is equal to summation I is equal to 1 into wi into xi. From that relation we can get this w. Simply that y is equal to w into x, right? What is w? W is equal to x into y transpose. That's what here we mentioned. So there is nothing but weight matrix. So here by using this weight adjustment we are going to get the required performance, because in that the required weights, in what way it should be there, that will be decided by adjusting that weights. Next method is gradient descent learning. So the name itself, it suggests that gradient descent learning, that gradient, error gradient, here we take that as error gradient differentiation. Okay. So this method is based on the minimization of error, which is mentioned as capital E, minimization of error, defined in terms of weights and the activation function of the network. So we need to get that error function which is in terms of the activation function and weights. E should be the function of W and activation function. Hence it is required that the activation function employed by the network is differentiable, because we are going for that gradient method. That means your weights and activation function should be differentiable, as the weight update is dependent on the gradient of the error E. Here weights updation or updating the weights is depends on the gradient of that error. Let us assume if delta wij, change in weight, delta wij is the weight update of the link connected between the ith and jth neuron of the two neighboring layers. Ith and jth neuron, the corresponding connection link change in weight is nothing but del wij. Ij is nothing but the two neurons. The corresponding change in weight of that connection link is nothing but del wij. Del wij is defined as the change in weight between the ith and jth neuron connection link is defined as follows. Del wij is equal to neta into del E by del wij. So here dou E by dou wij. Del wij is equal to neta into dou E by dou wij. Here neta is nothing but learning rate parameter, and where dou E by dou wij is the error gradient with reference to that wij connection weight. What is the gradient? Error gradient is nothing but dou E by dou wij. E is nothing but error, right? That error gradient with respect to that wij is nothing but dou E by dou wij. So how can you find out that del wij change in weight means neta into dou E by dou wij is nothing but the change in weights, where neta is a learning rate parameter that needs to provide. So this is, in this way we can go for the gradient descent learning. So here as E is a function where E is nothing but error, it needs to be the function of weights and activation functions which are differentiable, dou E by dou wij. That E function need to be find out to use this gradient descent learning method. Next one is competitive learning. So here name itself suggests that there is some competition, there is some uh, strategy to get that competition. Here the neurons which respond strongly to the input stimuli have their weights updated. It means which responds strongly, their weights only need to be updated. Let us take when an input pattern is presented, all neurons in the layer compete. So all neurons in the layer compete and the winning neuron undergoes weight adjustment. So for that input data, all the neurons will compete and which will win. That neuron alone undergoes to that weight adjustment. Here that's why it is called winner takes all strategy. All the connection link weights are not going to be updated. So based on that, strong approaching connection links or neurons only will be updated. So that's why it is called the competitive learning. So all the neurons may or may not activated in this learning, but the activated neurons, and by competing with other neurons, the neurons which are competing with other neurons, and it will try to retrieve the data. Based on that, the corresponding connection links weight will be adjusted. Let us take, we are having some 5 neurons between 1 and 2, between 1 and 3 connection links, and the corresponding neurons 3 and 4 neurons alone, it is active and it is trying to retrieve that information from that input layer. Then the corresponding connection link weights only will be updated in this competitive learning. The remaining neurons connection links weights will not get updated. That's why we will not take all strategy method. So next one is stochastic learning method. So here the weights are adjusted in a probabilistic fashion. So in the probabilistic fashion, the weights need to be adjusted. As an example, if we see that it is evident in simulated annealing, that means here in stochastic learning method, always we need to find out that global maxima and global minima. The trends will move towards that minimization function or maximization of the function, depends on your applications, what function, whether that function need to be minimized or maximized. So the annealing process simulated annealing process means in that it will try to get that minimization process or maximization process. So this learning mechanism is employed by the Boltzmann and Cauchy machines, which are a kind of neural networks. Stochastic learning method is provided by that another type of machines. These are called Boltzmann and Cauchy machines. So here these are the various learning strategies. So all these are available methods. We are not going to design. All these are available methods. We need to provide the inputs and we need to choose the proper architecture of the ANN, and we need to choose the proper learning strategy for that ANN. Then we will get the output, whether we need to go for hidden layers or whether we need single layer, multi-layer with more hidden layers. That depends on applications. We need to choose that particular architecture and we need to employ one learning strategy. Then we can get the outputs. So these are the classification of learning algorithm. So what we have discussed. Generally, neural network learning algorithms or learning strategies are basically divided into supervised learning, unsupervised learning, reinforced learning. The supervised learning is based on the error and the reinforced learning method is based on the output. Again, supervised learning is divided into two categories. One is error correlation gradient descent method, another one is stochastic method. So what we are seeing again, error correlation gradient descent method is divided into least mean square or backpropagation. Here in the stochastic method or error correlation descent method, always your weights need to be adjusted around the mean value of that error. Some optimum value of error will be there, values will be there. Around that value it will need to be adjusted. So that's what least mean square and backpropagation method. This we'll see in the coming classes. Again, unsupervised learning method is classified into two types. One is Hebbian learning, another one is competitive learning. So this is a classification of learning algorithm what we have seen so far. In detail, we'll see in further classes. Thank you.